With this question, I'm going to try two methods. One is the Venn diagram, the other is the tree diagram. Okay, in the question, we have three different coins, A, B, C. Coin A is fair with a head on one side and a tail on the other side. Coin B has both sides heads. Coin C has both sides tails. You pick one of these. So you pick just one coin and flip it. If you see heads, what's the probability that the other side is also heads? Meaning, if you see a head, what's the probability that the coin is B coin, right? Because B has both heads on the two sides. When you are given a situation that you do several different things, now here you do two things. First, you pick a coin, then you flip. So when you have different actions that you have to do sequentially, just think in the same order as what you would do in reality. So you can't physically flip a coin first and then pick it. No, you first need to pick a coin and then flip. Okay, let's think of a Venn diagram. If we have a total sample space here, the big rectangle, we divide into three parts equally. Because we have three different coins, we pick one at random. What's the probability that A is picked? It's a third, then B a third, so on. That's why we have divided the sample space into three parts for the three coins. And then the next action, you flip. I define H for head. Because A is a fair coin, the probability to have a head or tail would be half-half if we have coin A. To do half-half, I'm not going to use a circle here. I just shade half of the area of this A event. So I divide it by this diagonal line. So this lower triangle is shaded for head. To describe this shaded triangle using the H for head and A for coin A, I have A intersect H for this shaded triangle. And then the blank triangle on top of this would be A and H prime. So it's coin A and we have a tail, so H prime. So now I fully described the two regions inside A. Now for B, coin B has two heads. So no matter how you flip it, you will see head. So that is B intersect H. For C, coin C has both sides tails. So you will not see H at all. You would see C and H prime. So now the sample space has divided it into four different parts. To answer the question, let's see if we are ready. If the coin you flip gives a head, what's the probability that the other side is head? So we have a head. What's the probability you have coin B? That's the probability to have the coin B given we see a head. For the conditional probability, with the Venn diagram, even if you rely on the area of the shaded region, now H has two parts. One is this triangle, the other is the rectangle on its right-hand side. If we randomly pick an outcome inside this H, so in this shaded region, what's the probability that you pick from B? So based on the area, you can already tell that it's 2/3. Of course, you can write the equations and do a lot of other formulas to get this result. But I'm not going to show this here because I want to build a tree. On the tree diagram, we'll see a lot of different probabilities and we'll use those to calculate again this final answer. Let's start thinking of a tree diagram. To make the tree, Remember of the two actions, we first pick a coin from the three. Three coins A, B, C, they have equal chance to be picked, so it's a third for everyone. If coin A is picked, the probability to show a head when you flip it is half. To show a tail is the other half. If we have coin B, the probability to have a head is 1 because both sides of coin B is a head. If we picked C, so given the coin is C, the probability of having H would be 0. So I only show non-zero probabilities here. That's why I have the probability of H prime. So the probability to see a tail given the coin is C equals 1. So in the end, we have the 4 probabilities. These 4 probabilities are for the 4 events that we can relate back to the Venn diagram. So exactly those 4 regions. Now let's try to write the probability of B given H. So the probability to have coin B given you see a head when you flip the coin. Conditional probability, we can write it as a ratio. Now, where to find B and H? B and H is the 3rd probability on the tree diagram in the end. Now, where to find probability of H? H appears in 2 of the 4 probabilities in the end of the tree, so you add them. So we do all these calculations and the same answer. So I picked this question to explain if you have a question that looks so complicated that you don't know where to start, then just relate yourself to this situation. If you are given this job to do those things sequentially, where should you start? Right? Solving a question can be more intuitive instead of you just jump into the equations and look for formulas. That might be more confusing.